In this lesson, we'll be looking at algebraic fractions, and this is a continuation of our WAEC revision series. And since it is not a full tutorial on algebraic fractions, it's just a revision. I'll go straight into questions, and I'm using the New General Mathematics for SS3. The revision part of it will be open towards the center of that textbook. There is a revision part that is arranged according to the current WAEC syllabus. That is exactly where I'm taking all my questions from. So the first question here says simplify 3x minus 2 over 5 plus x plus 1 over 3. So if I have a fraction like this, 3x minus 2 over 5 plus x plus 1 over 3. Just like we used to solve the normal fractions, the common fraction without an unknown variable here. We have a common fraction like this. The first thing we do is to look for LCM of the denominator. So in this case, the LCM of 5 and 3 is 15. So 15 divided by 5 is 3. Then we multiply that 3 by the numerator. So I have 3 times 3x minus 2 plus 15 divided by 3 is 5. 5 times x plus 1. Now, distributing this, 3 multiplied by 3x is 9x, and 3 multiplied by negative 2 is negative 6, plus 5 multiplied by x is 5x, and 5 multiplied by 1 is 5, all over 15. Collecting like terms, we have 9x and 5x are alike since both of them have x. 9x plus 5x, then minus 6 plus 5, all over 15. 9x plus 5x is 14x, and negative 6 plus 5 is negative 1, all over 15. There's no way we can reduce this fraction below this, so this is our answer, 14x minus 1 over 15. Example 20 says a minus 4 over 2a minus 9b minus 2 over 6b plus 1. Okay, how do we solve a question like this? Again, we have different denominator here, 2a, 6b, and 1. So let's assume there's no a and b. The LCM of 2 and 6 is 6. Then when we put a and b into consideration, the LCM of 2a and 6b will be 6ab. 6ab. And 6ab divided by 2a, 6ab divided by 2a. A will cancel. 6 divided by 2 is 3. Then add the b there, we'll have 3b. Now 3b will multiply by the numerator. 3b multiplied by a minus 4, and minus 6ab divided by 6b. 6 will cancel, and it's supposed 6ab divided by b will cancel. So we are left with only a. We have a multiplied by 9b minus 2. Then plus 6ab divided by 1 is 6ab. 6ab times 1 is 6ab. So let's distribute this 3. 3b times a is 3ab. 3ab. And 3b times negative 4 is negative 12b. Minus a times 9b is 9ab. And minus times minus is plus. A times 2 is 2a plus 6ab all over 6ab. Let's collect like terms. 3ab, 9ab, and 6ab. They are all like terms, so let's bring them together. 3ab minus 9ab plus 6ab. Then 12b, there is no like term to that. And 2a2, there is no like term to that. So they are alone all over 6ab. And let's add the positive first. 3ab and 6ab are positive. And when you add 3ab to 6ab, that is 9ab. So 9ab minus this 9ab here minus 12b plus 2a over 6ab. This is gone. So we're left with negative 12b plus 2a over 6ab, which I can write as if I'm bringing the positive term plus 2a minus 12b over 6ab. 2 is common there, so we could factor that out. That will be 2 times a minus 6b over 6ab. 2 here 1, 2 here 3. So our final answer is a minus 6b over 3ab. Example 21, we have quadratic expression here. 6 minus x minus s squared over s squared minus 4. Let's factorize both the numerator and the denominator. And if I have to factorize this numerator, let's do that separately. If I have 6 minus x minus s squared, to factorize this, first of all multiply the first term by this, which give me this. Then I'll look for two factors of negative 6s squared that can add up to this. That should be negative 3x and positive 2x. Let's see, by substituting this into this, if we can factorize that. If it doesn't work, then we'll look for other factors. I have 6 minus 3x plus 2x minus s squared, which will be, in this first bracket, 3 is common, so I have 3 brackets, 2 minus x. In this second bracket, s is common, so I have plus x bracket 2 minus s, 3 factorized. So this gives us 2 minus s as a common factor, then 3 plus s, 3 plus s. So this numerator factorizes to 2 minus s and 3 plus s. While the denominator, looking at this is a perfect square, so we can apply difference of 2 square here. So I have s plus 2 and x minus 2. Recall that 4 here is a perfect square, so remember that perfect square or difference of 2 square, rather say a square minus b square is equal to a plus b and a minus b. So this expression here is exactly like this. That is s square minus 2 square, because 4 can be expressed as 2 square. So I applied this to get this. I want to reverse this so that it will be the same thing like this or like this, so that I can cancel out something there. And to do that, I will have to multiply the whole of numerator by negative 1. So that when I do that, I'll have minus, let me bring the, I have negative 3 plus s and s minus 2 all over s plus 2 and s minus 2. So that this term cancels this. So the essence of multiplying by negative 1 is so we can reverse, would I say reverse? It has changed the arrangement of this term here. Remember it's 2 minus s here, but I want to make it the same with this denominator. So I multiply through so I can change the order of the terms so that one at least can cancel out. So we have negative 3 plus x over s plus 2 as a final answer. In the next example, which is example 22, says 3a cubed over 3a squared minus 6ab plus 4b cubed over 2b squared minus ab. Here, let's factorize these denominators so we can cancel out some terms. So this will be 3a cubed over, in this expression here, 3a is common to the two terms. So if I factor it out, 3a into a minus 2b, m plus 4b squared cubed over, again, here we have a common factor which is b into 2b minus a, so that this 3 can cancel this 3, and one of the a will cancel one a here, so I'll be left with only 2a. This b will cancel one b here, I'll be left with 2b, so that my expression now becomes a squared over a minus 2b plus 4b squared, excuse me, over 2b minus a. Now I want to make sure that this term and this term are the same. So to reverse this very one, to make it like this, I will have to multiply through by minus 1. And if I multiply through by minus 1, that means this plus will change to minus, so that my expression now becomes a squared over a minus 2b. Instead of this plus, it becomes minus since I want to change the arrangement of this. So I'll have 4b squared over a minus 2b. Now I have the same expression as the denominator. And remember that when adding or subtracting fractions, if the denominators are the same, we can add or subtract the numerators, so that this now becomes a squared minus 4b squared over a minus 2b. And this a squared minus 4b squared is, again, we can apply difference of 2 squared there. We can write that as a squared minus 2 squared b squared over a minus 2b. So it becomes, when we apply difference of 2 squared, it becomes a plus 2b and a minus 2b over a minus 2b. So that this a minus 2b can cancel this a minus 2b. Our final answer becomes a plus 2b. Example 23, we have x over s minus 3 minus s minus 1 over s plus 2. Here, look for LCM of x minus 3 and x plus 2. And the LCM will be x minus 3 times x plus 2. And we divide this by this. Look at this, x minus 3 and x plus 2 divided by x minus 3. X minus 3 will cancel out, so we'll be left with x plus 2. Multiply that x plus 2 by this, so I have x times x plus 2 and minus, again, when we divide this by this, s plus 2 will be gone, we'll be left with s minus 3. So we multiply that by this, I have s minus 1 times s minus 3. So that when we distribute the first expression, x times s is s squared, s times 2 is 2x, minus, when we expand or foil this, x times s is s squared again, s times negative 3 is negative 3s, negative 1 times s is negative s, then negative 1 times negative 3 is 3, all over x minus 3 and x plus 2. This will give us x squared plus 2x minus s squared plus 3. Okay, let's add this first. This minus 3x minus 1x is minus 4x. Minus 4x plus 3 all over s minus 3 and s plus 2. That will be s squared plus 2x minus times this is minus, and minus times minus 4s is plus 4s, minus times plus is minus, all over s minus 3 and s plus 3, plus 2 rather. This will go, s squared minus s squared is 0, then 6s, that is this plus this is 6s, 2x plus 4s, 6s, minus 3 over s minus 3 and s plus 2. 3 is common there, so if you factor it out, we have 2x minus 1 over x minus 3 and s plus 2. That is the final answer there. And we have some WAEC question here. The first one says 3m over 2n minus n minus 1 over 5n plus n minus 2 over 10n. Given that n is not equal to 0. So we have to simplify this. How do we do this? Now, the denominators are not the same, so we need to look for LCM of 2n, 5n, and 10n. The LCM is 10n. 10n can divide all of this. 10n divided by 2n is 5. That is 10n over 2n, n will cancel, and 10 divided by 2 is 5. You multiply the 5 by this 3m, that will be 15m minus 10n divided by 5m, n will cancel, 10 divided by 5 is 2. Multiply the 2 by the numerator, n minus 1, n plus 10n divided by 10n is 1. 1 times n minus 2 is n minus 2. So this will be now 15m minus 2 times m is 2m, and minus times minus is plus, 2 times 1 is 2, m plus this, m minus 2 over 10n. Collecting like terms, all the m, let's bring them together. We'll have 15m minus 2m plus m plus 2 minus 2 over 10n. 2 minus 2 is gone. M plus 15m is 16m Then 16m minus these 2m is 14m. We have 14m over 10m. 2 here 7, 2 here 5. So our answer is 7m over 5m. X minus 1 all over x squared minus 9. Okay, for this, let me first of all factorize this expression here so that I will have 1 over x minus 3 minus 3 times x minus 1 all over, this is a perfect square, x squared and 9 squared, so I can apply difference of 2 squared there. So I'll have x plus 3 times x minus 3. So now looking for LCM of this and this. LCM of x minus 3 and this x plus 3 and x minus 3 should be x plus 3 and x minus 3. So that when I divide this by this, x minus 3 will be gone. I'll be left with only x plus 3 multiplied by 1. So I'll have x plus 3 here, and minus x plus 3 times x minus 3 divided by this will be 1. And 1 multiplied by this, I have 3 times x minus 1. So that when I distribute this, I'll have x plus 3 minus 3x, then minus times minus is plus, all over x plus 3 and x minus 3. Let's collect like terms, this and this, and this and this. I have x minus 3x plus 3 plus 3 all over x plus 3 and x minus 3. X minus 3x is minus 2x. Then 3 plus 3 is 6 all over x plus 3 and x minus 3. 2 is common here, so we factor that x plus 3 over x plus 3 times x minus 3. So x plus 3 will be gone. We'll be left with minus 2 over x minus 3. That's our final answer. Question 23. Have 3x plus 2 over 3 minus x minus 1 over 4 minus 5 over 12. Again, we need to look for LCM of this fraction 3, 4, and 12. The LCM is 12 itself. 12 divided by 3 is 4. Multiply the 4 by the numerator. So I have 4 times 3x plus 2 minus 12 divided by 4 is 3. Multiply the 3 by the numerator. 3 times x minus 1. Then 12 divided by 12 is 1. Multiplying 1 by 5 is 5. And distributing this 4, we have 4 times 3x is 12x. 4 times 2 is 8. Negative 3 times x is negative 3x. Then negative 3 times negative 1 is positive 3. And minus this 5 all over 12. Collecting like terms, we have 12x minus 3x plus 8 plus this 3 and minus 5 over 12. 12x minus 3x is 9x. 8 plus 3 is 11. 11 minus 5 is 6 over 12. 3 is common to this. So let's factor out 3. 3 into 9 divided 3 is 3, 3s. Then 6 divided 3 is 2 over 12. 3 here 1, 3 here 4. So we have 3x plus 2 over 4. 24, we have 2x over x squared minus y squared plus 1 over y minus x. Let me factorize this using difference of 2 squared. So I have 2x over x plus y and x minus y plus 1 over y minus x. I want to make this y minus x to take this form. As is, instead of having y minus x, I want it to be x minus y. And for me to do that, I will need to multiply this by negative 1. So if I multiply this time by negative 1, my expression becomes 2x over x plus y and x minus y minus 1 over x minus y. The plus changed to minus because I reversed the order of this second expression there. The LCM of this and this is x plus y and x minus y. X plus y times x minus y. And this divided by this will be 1. 1 times 2x is 2x. This divided by this, only this will cancel out. I will have this left. I have minus 1 times x plus y, which is 2x minus x minus y over x plus y and x minus y. 2x minus x is x. I have x minus y over x plus y times x minus y. X minus y divided by x minus y is 1. So my final answer is 1 over x plus y. Question 25. We have 3 over x minus 15 over 2y divided by 6 over x, y. Applying Bodman's, we need to solve the expression in bracket first. And looking for LCM of x and 2y. The LCM of x and 2y is 2xy. 2xy divided by x is 2y. If I take 2xy divide x will cancel. We are left with 2y. So multiply that 2y by 3. That is 6y. Then 2xy again divided by 2y. Y will cancel and 2 will cancel. We'll be left with x. X times 15 is 15x. That is the expression in brackets. Then divided by 6 over xy. This will be 6y minus 15x over 2xy. When dividing by a fraction, the sign of division will change to multiplication. Then we multiply by the reciprocal of this fraction. So I have x over xy over 6. Xy will cancel xy. So that I have 6y minus 15x over 2 times 6 is 12. Now in this numerator, 3 is common since 3 can divide 6 and 15. So factor it 3 into 2y minus 5x over 12 over 12. 3 here 1, 3 here 4. So our answer is 2y minus 5x over 4. And 26 over 1 minus s squared over s minus s squared. Let's apply difference of 2 squared here. The numerator plus 1 is a perfect square and s squared is also perfect square. So I have 1 plus s and 1 minus s all over. S is common here. I have s into 1 minus s into 1 minus s. So 1 minus s will cancel it. So my answer is 1 plus s over s. 7 we have 18s squared minus 8 all over 6s squared minus 11s minus 10. In the numerator, 2 rather is common. So let's factor that out first. 2 here will give me 9s squared and 2 here will give me 4 all over. This is quadratic. So if you factor that, to factorize that, let me do it separately here. 6s squared minus 11x minus 10. You multiply 6s squared by this 10 to give me negative 60s squared. And 2 factors of 60s squared that can add up to negative 11, negative 15x, and 4x. Remember that 15s times 4 is negative 15s times 4s is negative 60s squared. And negative 15s plus 4s is negative 11x. So we will replace these middle terms with the factor so that this expression becomes 6s squared minus 15x plus 4x minus 10. Now if I group this by 2 by 2, I have 6s squared minus 15x, then plus 4x minus 10. In this first bracket, 3s is common. I have 3s into 6s squared divided 3s is 2x. Now 15s divided 3s is 5. Plus, in this second bracket, 2 is common. 4s divided by 2 is 2s, and 10 divided by 2 is 5. So I have a common factor 2s minus 5. 2x minus 5 as my common factor, then I group this and this together. 3s plus 2. Now, excuse me, now that I have the numerator in factorized form, I'm going to replace it in my fraction. What was the factors now? 2x minus 5, 2x minus 5, and 3s plus 2. 3s plus 2. Now factorizing the expression up there, we have 2 multiplied by, this is a perfect square, so 9 can be written as 3 squared, then s squared, minus 4 can be written as 2 squared, then all over 2x minus 5 and 3x plus 2. So that I can apply difference of 2 squared in this numerator. And if I do that, I'll have 2 multiplied by 3x plus 2 times 3x minus 2 and all over 2x minus 5 and 3s plus 2. So this 3s plus 2 can cancel this. I will therefore be left with 2 times 3x minus 2 over 2x minus 5 as my final answer. Okay, now we'll move on to the final question here, which is x squared minus y squared all over x squared plus sy. Applying difference of 2 squared to the numerator, we'll have x plus y and x minus y all over. In the denominator, x is common, so we'll factor that. So we'll have x plus y. X plus y will cancel x plus y, so I'll be left with x minus y over x. My final answer.